our monthly series on everything data management. This is Deborah Henderson. I'm former president of ERMAC and your moderator today. ERMAC, the Information Resource Management Association of Canada, is bringing you these monthly virtual sessions for information, continuing education, and updates from around the world. Today, we are looking for volunteers to help us out on an ongoing basis, not just because of recent months and switch up to our virtual format. And so please, if you're interested, we'd love to have you as an interested member on our board, or even in an official capacity on our board. This would give you experience in non-for-profits. It's all volunteer, and also give you a platform to exercise your leadership skills and develop more. So please consider us and reach out to us. Look for us at ermac.ca. Today's session, getting on with it, we're doing detective data work, all emergent AI practices, and how that fits with anti-money laundering. We have today two experts, Roger Van Dome and Dr. Fiona Brown, to help us out here. Roger, based out of the Toronto area, has built a career on fundamentals of data analytics, predictive modeling, and related decision making. He has over 20 years of experience and in the credit bureau area, creating credit scores for around the world. In our pre-meeting just now, he mentioned he's working with firms in Africa. So he has an unmatched, outstanding skill set in the field of predictive modeling, and has completed numerous studies and research on decision heuristics and biases, developing reasoning methods and processes around systemic design and game theory. So he holds a master's degree in applied mathematics from Paris University, an MBA from Queen's, and a master in defense studies with the Royal Military College. Welcome, Roger. Dr. Fiona Brown will then follow up. She is head of artificial intelligence at a vendor at Detactics, with over 16 years of research and industrial experience, and she's based out of North Ireland. She's responsible for overseeing the integration of AI and ML, machine learning solutions, into Detactics platform, which provides data quality and matching at scale to clients in banking, financial services, and government, and they're an international firm. Prior to this, Fiona was a lecturer in computing science in Ulster University, teaching data analytics, and a research focus on applied artificial intelligence and data integration. She was a research fellow at Queen's University in Belfast, now this is Queen's in Belfast, and a senior software developer at PathXL. She received a BSc honors degree in Comp Sci from University Ulster, Belfast in 2004 and 2009, a PhD on artificial intelligence in bioinformatics at the University of Ulster, for her work on integrative data analysis models and tools for the prediction of protein-protein interaction networks. She's published over 50 articles in peer-reviewed international journals and conference proceedings. Welcome, Fiona. Now, where we're going to work is hopefully very interactive here. Roger's going to set the stage on, the history around AI in AML and where we are now, as strategies and so forth, and then pass it over to Fiona. So without further ado, I'll pass the microphone and the screen over to Roger.
Thank you very much, Deborah, and good evening, everyone. So let me share my screen on the presentation side, what you should see now. So yeah, welcome to this presentation. So I'm Roger Vendôme, and I'm the chief data scientist of the NEOS group. So in a very quick word, if that works, yes. So the NEOS group is based in Montreal and in Toronto, in Canada. We do analytics and consulting in artificial intelligence, as well as training in all level of technology. We host some AI-powered platforms as well that are already made, and we help companies to go in their way of innovation and research and development. So today we are going to talk about money laundering and anti-money laundering. So in order to understand better what is the anti-money laundering, we will try to understand first what is money laundering. What is it, where it's come from, what are the definitions, the methods, and the magnitude. In order to counter it, we have first to understand really what it is. And the purpose is to give you an idea of the complexity of it, so you can match the complexity of the methods that we're obliged to use in order to counter it. So then we will see the anti-money laundering, what are the methods that are used today, with the role of artificial intelligence, which is extremely important currently on it. We will finish with the challenges and the limit of these methods, and that will be the bridge for the next presentation, for Fiona's presentation. So let's see first what is money laundering. So first, money laundering, the definition that you can see here is an illegal process to conceal the origin of illegal funds. So when you are when you have a criminal activity and you receive money, most of the time in cash, you have to put this money back in the system and try to be sure that it cannot be tracked, and you cannot use it normally after having this money back in the system. So to clean the money. So that's why we call it money laundering. Because the purpose is to have dirty money and the end to make clean money. So when did it start? Basically, all the issues started with the prohibition in the US in the 20s. And we can state that the first act of anti-money laundering has been the arrestation of Al Capone in 1931 in Chicago. That because it was impossible to have him for all the crimes that he committed, the only way we found was to arrest him for tax evasion. So that was the first, and is defined as the first anti-money laundering act that existed. We had a resurgence of it in the 80s. The 80s saw a peak in drug trafficking all around the world. So all the dirty money that was coming from drug trafficking had to be reinstalled in the traffic, has to be cleaned. And we had a big resurgence of activities in money laundering activities. Then on the other side, the really increase of efforts in anti-money laundering and the structure of it really started worldwide after 9/11. 9/11 gave to the US, because it's existed before in the rest of the world, but really gave to the US an idea and the conscious of the existence of terrorism and the need to put together a lot of means. So then we saw a flourishing of different kind of legal bodies and structures and agencies that started to really dedicate a lot of efforts and a lot of means into the anti-money laundering. And we're going to see why, because obviously money laundering is strictly linked with terrorism. So what is the principle? How does it work? Basically, we have three phases in money laundering that are called placement, layering, and integration. So how does it how does it work? First, it starts at the top of the screen here with the criminal activities. So you have the basic main criminal activities that are mainly theft and robberies. Obviously, you get some cash because you just stole it. All kind of traffics, drugs, weapons, and humans. Prostitution, gambling, and racket that are mainly using cash as well. Corruption, at all level of corruption, that is an exchange of cash most of the time. And tax evasion, that is also generating cash. So you have all those criminal activities that are generating cash and dirty money. So this cash has to be clean. The first thing is placement. The money has to be integrated, that is put in the system. Most of the time it's going to be through a financial institution, a bank. So the money is going to be deposited in the bank. So you see the first thing there that can be an angle to try to prevent it. So the money is going to be deposited in the bank. That is the first thing. It's not mandatory. Sometimes this first step of placement can be skipped and go straight to the layering, because it's a very, very delicate and more for the criminal activities to be able to execute this placement. Another way to do it, if you are not going through a bank, is also to invest, and most of the investment currently are done in real estate. Look at what happened in Vancouver and British Columbia, usually with money coming from China, and there has been, you will see in the news during the last year, there has been a lot of issues in money laundering through the real estate investment. So that's the first thing, is placement. We put the money into the circuit. Then the layering, the second phase. The layering is basically the cleaning by itself. It starts, for example, as we see here, with the transfer on the money to the account of the company X. We just put the money in this account. Then it starts a cycle of invoicing and payment. So we can do a wire transfer to an offshore bank, then loan money to a company Y. Then the company Y is going to pay a false invoice to the same company X. And we do it again with another X company, another Y company. And we do that several times. Sometimes it's going to be done 10 times, 50 times. It can be hundreds of times until you totally lose track of the origin of the money. And if you try to understand where the money is coming from, you are going to see all a series of invoices that are going to give legitimacy to this money. So then this money, after the layering process, is on a bank account, is clean and legitimate. As far as you can go back, it tried to find the origin of the money. So the third phase is the integration. Now this money is going to be used. And it's used mainly in three purposes. The first one is the criminal wealth, to ensure the quality of life of criminals. They are going to reinject the money by buying luxury goods. The second one is to reinvest in the business. So will be the reinvestment in the criminal activities. And the third one, which is the most concerning, is terrorism. Then you have another loop that is going to terrorism and going back to criminal activities. Most of the terrorist entities are actually organized crime that is hiding behind religion most of the time. So you have a very, very close loop between the two, especially on everything that is traffics. Terrorism is usually financed by all kinds of traffics, mainly drugs and weapons, in some part of Africa, and humans as well. So you see the loop that is going there, and after that is going back in the circuit. So that in order to understand the principle and start understanding where are the weaknesses there. It is a very, very complex process. So you can start understanding how we will be able to fight it. First one is on the placement, and then we will see on the layering. How do we do the layering? Layering, we have plenty of methods.
Roger, sorry to interrupt, but there's a question on the previous slide you might be getting into in a little bit, but it's how much does Bitcoin / cryptocurrency adding to these problems?
It is basically adding a lot of issues in the layering process in order to track the origins of the funds. The fact is the issue that we have is to find origins, track origins, see where it's coming from. And on the other side is to try to give legitimacy. So everything that is cryptocurrencies currently, by the speed of the transactions and the multiplicity of the transactions with the number accounts, allow very often criminals to hide behind. And the second point is that it created a second parallel economy. So you can be paid in cryptocurrencies, buy goods in cryptocurrencies without getting inside the normal banking system. So you can create a total parallel system where nobody can do anything. So that's the two issues that we have currently and on which we are fighting.
Fascinating. Thank you.
So the methods that are used, here you have only the list of the most important ones. There is a very long list of methods and some can be extremely complex. On the layering process, so for example, you have the smurfing. Smurfing that is already called structuring is actually dividing the amount of money that has to be transferred in small amount of money. So it's small layers. We will see that in the anti-money laundering measures, one of them is to report transactions if they are above a limit. For a long time in Canada, it has been $10,000. I think that recently it went down to $1,000. But if it is $10,000, you do not want the transactions to be reported, so you are going to have transactions of less than $10,000. So if you have a large amount of money to transfer, you will divide it is as many transactions as necessary that will be under the limit of mandatory reporting by the financial institutions. So that's the smurfing. The bulk cash smuggling is a very old method, is basically the suitcase of banknotes that you take in a plane, in a train, or in a car, cross the border, go in another country, in a tax haven, put it in the bank. That's what you see in the movies. You come with a suitcase, you put the suitcase in front of the cashier, open it, banknotes, put it in a deposit account. That's the bulk cash smuggling. More and more difficult, of course, because you have to cross the borders.
Are there also things on the banknotes itself? There's lots of security on banknotes themselves now across the world that alert perhaps through the scanners at the border that you're bringing a whole load of cash.
Yes, it is possible to detect them now. It's more and more difficult to smuggle big amount of cash through the borders. But it is still done. It's still done very, very intensely, actually.
There's a big legal case here in Canada of art forgery of a very famous Canadian artist, Norval Morrisseau, where some people were faking his art and pretending they were getting the money for this art, whereas they were actually laundering money for drugs.
We are going to see that in the next one, which is the trade-based laundering. That is exactly what it is. So the next one is the cash-intensive business. The cash-intensive business, you all saw it in the photo that is just beside in Breaking Bad with its famous car wash. Is basically to run a business that is running on cash, and you have plenty like the strip joints, the massage parlors, the bars, the restaurants, the car wash, all those businesses that are cash intensive and have a very, very small amount of variable cost. So it's very difficult to track the amount of activity by the variable cost. So that's what you see in Breaking Bad if you saw it. A very nice way and very efficient way to clean the money is actually to pretend that you have more activity than you had and deposit the money in the bank as it is the revenue of your business. And then it's going back in the circuit and it's clean at the end. Casino, of course, because it's very cash intensive. So casinos are a big place of money laundering, as well as gambling on a certain way. You have some specific games where the odds are some level and you can accept to lose part of it because recycling the money and cleaning the money has a price. So you will, according to the odds, accept a loss in order to have the money back. You arrive in a casino, you change your money into chips. You play just a little bit, you go back to the cashier, you change your chips in money, and that's it. You have the profit of your game and the money is back in the transactions. The trade-based laundering is what you were just talking about. It is basically to falsify the value of an item through all the transactions by invoicing and payment. So you over or under invoice an item in order to have more money than necessary in the circuit. That's what we saw mainly with art, because art is extremely difficult to assess. It's all a matter of perception and market. So you can have one piece of art that is going from a very, very high level of value and very low according to the transactions. And nobody can say anything because it's just a perceived value. So that is done very, very often as well. Something that we all heard about are the shell companies and trusts that are in the tax havens. So you are going in an island somewhere in the Caribbean, you open a shell company that is going to hide your identity. You are going to have a straw man that is going to be paid in order to be the president of your company, will answer all the questions, and you are not going to pay tax there, and nobody will know exactly who is behind this company. And you can operate it on a distance. The round tripping is same thing, that it's using the shell companies, but in order to circuit the money. So it's actually when this company is managing a lot of transactions and you are going to those islands, include the money in the company. So deposit money in the company, put it in the bank, in an offshore bank, and then go back in the circuit. So that's the people that are going to the Caribbean in private plane with suitcases full of banknotes. The video game is an interesting one. It's quite new. Some video games, like Warcraft, for example, are authorizing transactions within the game. So you can put money on an account in order to play with the game. And when you finish, you can take this money back. So when you take this money back, then you have a clean origin of the money. So you have an intensive usage of video games in order to have the money in and out from gaming accounts. And that is used as well quite often. It's a pretty new one. And cryptocurrencies, of course, we just talked about it. The cryptocurrencies that are a parallel economy and a parallel way of getting paid and being able to use the money in order to acquire goods. I can have criminal activities like we see, for example, with the ransomware. A ransomware will ask to be paid in cryptocurrency, so you cannot track it. It is in a parallel economy. It's not in the banking circuit. And then you can use this money in order to buy your car, buy luxury goods, whatever, most of the time on the dark web. And and that is untraceable. It's more difficult.
Hey, Roger. Oh, yeah. Sorry. I was just going to ask a question about one of these items. So a lot of these seem to be like a person has a lot of money, and so they'll go into a cash-intensive business and everything's kind of on their side, or they'll have a shell company and they're taking care of everything. But the video games option seems really interesting, since it's relying entirely on this third party supplying you this service. And I guess them turning a blind eye to these huge amounts of transactions. With how new this is this like, how have these video game companies, do they just smile and nod and say, well, that's a lot of money we just got and gave away? Like, how do they get through this without it being very obviously something that should be a red flag for their company?
It is extremely difficult to manage because you are not without knowing that you have a lot of money that it is spent in some of those video games, a considerable amount of money. Some people would understand or not understand, but you can, and you have. I work with some video games that introduce me to how it is managed, and you have actually the customers, the clients, the gamers that are in three different categories. You have the minions that are not spending anything, people like me. Then you have the dolphins that are spending a reasonable amount of money. And then you have the whales that are spending an unreasonable amount of money. And when we say unreasonable, we are talking about hundreds of thousands, we are talking about millions of dollars that are spent by one person in a video game. So that is very, very difficult to control because how are you going to prevent that and stop it? So it is still thought about. You will see after we are going to talk about the legal bodies that are working on it, and it's part of the limits. It's part of the limits on what we can do legally or not in order to control some activities. Of course, they can report it, and after that, we still can try to track it. But the issue is that we have a lot of people that are doing that on a very, very legitimate way. So we will see later on that one of the issues in tracking and the usage of artificial intelligence is actually the false positive. We want to reduce the false positive because if we are tracking all the insane amount of money that are in transactions, we are going to arrest a lot of people that are doing very normal, legitimate transactions. So that's one of the issues. It's really not easy to manage.
And we have one question from the chat. Let me know if this is also going to be covered in a future slide because it feels like something that might be covered. From an exchange perspective, is there any attempt to evaluate exchanges, parties, commissions, and or exchanges, parties, commissions, and or the exchanged assets?
When you see exchange, what do you mean by exchange? Currency exchange or an exchange trading like the TSX? If it's on that, yes, it is obviously an issue as well with the commissions. Commissions is a big way of it's a big tool to clean the money. Yeah, everything that is commission can be sometimes on some trading at the limit of corruption. So if the money is too important, so getting a too high commission can be a trigger as well that we have to be very, very careful about.
Interesting. Thank you.
So a question that is often asked is what is the magnitude of that? Because it is hidden, it is extremely, extremely difficult to estimate. Many countries and many bodies, actually legal bodies, don't even try. We had to try, and the United Nations Office on Drugs and Crime tried to estimate it, and the latest estimation is between 2 and 5% of the global GDP. So if you translate it in US dollars, it's between 800 billions to 2 trillion US dollars that every year are laundered. So it's this amount of illegal criminal money that is cleaned and reinjected in the economy in order to be spent, as we saw it at the beginning, for the criminal wealth, reinjected in the criminal business or finance terrorism. So it is a considerable amount of money. that we are talking here. And obviously, it is a big issue that we have to fight. So how do we do that? The anti-money laundering started to be structured in 1989 by the initiative of the G7 countries, who created the Financial Action Task Force on Money Laundering, so FATF. The FATF is headquartered in Brussels and has those, so 7 countries originally, but now really worldwide, is organizing the anti-money laundering actions all around the world. One of their most important action has been to develop the 40 recommendations on money laundering that you can find on their website. One of the first important one is for a country to criminalize money laundering. It seems obvious, but money laundering is still not a criminal activity in some countries. So the first recommendation is, if you want to fight it, you have to criminalize it. So then we can use the law and we can prosecute the people. Because we can catch them. In some countries, you can catch them, but you cannot prosecute them because it's not a criminal activity. So FATF is organizing all those rules and these bodies all around the world. A few years after, in 1995, 164 countries, after signing on the FATF, decided to collaborate together on the financial intelligence units, and they created the Emergent group. Emergent is the name of the hotel in Brussels when it has been signed. And the Emergent group is actually formalizing the collaboration of all the financial intelligence units. Here in Canada, it would be FinTrack. So FinTrack is part of the Emergent group, where they collaborate and exchanging intelligence. They are basically intelligence agencies specialized in finance, and they exchange intelligence all around those 164 countries. For the little story, the headquarters of the Emergent group is in Canada. And it has been for many, many years until 6 months ago. The headquarters and the head secretary was in Toronto on Yonge and Eglinton. Very discreet, nothing outside, but they were at the third story, the third level of the building that is southwest of the Yonge and Eglinton crossing. They moved now in Ottawa for 6 months now. They are in Ottawa. So that is the body that is organizing all the cooperation between financial intelligence units on all the 160 countries. Basically, the result of that has been the creation of all a body of administrative reporting by financial institutions. So everything that we see today, that is the KYC/AML, is coming from there. So it's all these mandatory reporting of know your customer and anti-money laundering reports that have been that must be done and organized by the financial institutions, and that's what we are going to see. It's one of the very delicate points. And the need for judicial enforcement framework. So as we saw, it has to be criminalized, which is not always the case. So I would recommend, if you want to dig a little bit, to go on the website of those two organizations, mainly FATF, because the Emergent group is very, very specialized on everything that is intelligence, and it's more organizing. When the FATF has a lot of papers that you can download with, especially the 40 recommendations for the country, and gives a lot of examples, very often specialized on by industry. How to fight the money laundering in real estate, in insurance, in financial institutions, etc. So it can be very, very detailed. If it's something that is of interest for you, I would recommend their website that is very well done and very rich. So now our main subject, which is how do we use AI there? obviously, when you see the number of transactions that financial institutions we have to report, and the number of transactions that the intelligence units will have to analyze, we realize very quickly that a human will not be able to do that. It's too much. And it is part of the cat and mouse game with the criminal activities, is to try to lose the people that are trying to investigate by the amount of transactions and the complexity of the transactions. So very early on, when the artificial intelligence started to be more mastered, we realized that it would be the perfect tool in order to analyze. Because one of the principle of artificial intelligence is looking for patterns. And that's exactly what we are doing in anti-money laundering. We are looking for patterns, repetitive patterns, numbers on the timeline, something that happened already and that we can track. We are looking at the small signals that say something is wrong there, with the big challenge that is to try to reduce the amount of false positive, because it would be too easy and impossible to stop or investigate just because there is just an amount of money that is off track. Most of the time we are going to find false positives. And we are going to spend more time and money tracking the false positive than the money that we are tracking itself. So that is one of the issues. So it is the perfect area to use artificial intelligence because it's all in the definition. It's finding patterns, and we know we can do that. On the other side, the criminals know that we do that as well, and we try to cover the patterns. They will try to avoid working with patterns. They will try to counter patterns all the activities or mask the patterns. And for that, guess what? They are going to use artificial intelligence as well. So that's where it's becoming very, very difficult. Is that on the other side, you can have a criminal organization that is going to use artificial intelligence in order to randomize the transactions, automate the transactions, randomize it. So it is never the same amount, it is never at the same moment, it is never at the same date. So it will be extremely difficult for another AI to find the pattern. So it is really a game of cat and mouse that never ends. But it is the perfect area to use artificial intelligence, as we are going to see it with Fiona. So it's not easy. It's not easy. The challenges are, as I say, the resilience and the adaptability of the organized crime. They adapt permanently. We are not looking at a physical phenomenon that is repeatable. We are looking at something that is alive, that is managed by humans, and that is reacting and in purpose trying to not use patterns. So, and it's very, very adaptable. So that makes it extremely, extremely complicated.
Thank you, Roger. Is it possible to run over to Fiona now and start her presentation?
It's just the end. It's the last slide. So with the regulatory burden that is extremely complex as well, it's a challenge. And the limits that we are going to see, that's the hyphen with Fiona's presentation. Our challenge is the data quality, the data secrecy. We have to be very careful with the banks on the secrecy of data, and that is a matter of legal issues, and the data compatibility with all the different systems. And that's the challenges that we are going to pass to the specialist in artificial intelligence. That is Fiona.
Thank you, Roger. That was super. So interesting. I'd love to follow up with you again on the crypto side. It's very, very interesting. So I'm just going to share my screen now, and hopefully everybody can see this now. So hello everyone, and thank you, Deborah, for the introduction, and thank you, Roger, for that great overview of AML and fraud. So I head up artificial intelligence and machine learning at Detactics, and I'm going to do more of a deep dive into the machine learning side and explainability and where data lies in that as well. So just a little overview of who we are and what we do. So at Detactics, we are a company based in Belfast. So there are 50 of us, and we have presence in London, Milan, and New York. And we specialise in data quality management and entity and instrument matching at scale. We have clients in the financial and the governmental sectors, and we help them with tasks such as compliance to banking regulations and getting their data in line for activities such as anti-money laundering checking, knowing your customer, providing a single customer view, and so on. And we do this through our self-service data quality platform. So monitoring the quality of data is really important, and then the ability to then improve the quality and fix the quality of that data. And since 2018, 2019, we have invested in embedding machine learning into the Detactics platform, focusing on areas and how we can improve operational efficiencies and how we can improve data quality and data management using machine learning. So artificial intelligence and machine learning, there is a lot of information and hype about AI in the media. So we have a lot of articles out there saying, you know, AI is coming and it's going to replace us and our jobs, and automation is on its way. We view machine learning from a practical point of view. So machine learning is really, really good at taking processes which are manual and repetitive and then being able to automate that. And that's something that we have looked at within Detactics in the area of entity resolution. So I'm going to start off with a broad introduction to artificial intelligence and machine learning. You often hear these two terms used interchangeably, but there is a difference between the two. So artificial intelligence, what's interesting is that there is no real agreed upon definition of what AI is, but generally it can be construed as the capability of a computer to perform cognitive tasks such as decision making, visual perception, speech recognition, which we usually would attribute to a human. And then a subset of AI is machine learning. So these are our different algorithms and models, and you may be familiar with them. So you have algorithms such as logistic regression, naive Bayesian, decision trees, deep learning neural networks. And then what these algorithms do is that they learn from input data. And as Roger has said in his previous talk, they learn to identify patterns within this data, and they use these learned patterns to distinguish between outcomes. For example, a fraudulent and a non-fraudulent transaction. And you've got different flavors of machine learning approaches. So you've got supervised machine learning, unsupervised machine learning, and reinforcement learning. and also overlaps in between, such as semi-supervised machine learning. But at a broad level, supervised machine learning is where you have a model, and your model learns from a training data set or a big corpus of data, which is labelled. So going back to the example of fraudulent activity, these are transactions which are labelled as this is a non-fraudulent transaction, this is a non-fraudulent one, this is a fraudulent one, and the model learns from these labelled data. Sometimes you don't have labelled data, and in this case, you can use unsupervised machine learning, and this is where your model learns from unlabeled data. And what it's looking for there is that it's looking to uncover maybe particular clusters or segments or patterns then within that data that's able to separate it out into different clusters. And reinforcement learning, which is gaining traction, is models which continually learn and update from performing a task. An example of that is a computer algorithm learning how to play the game Go. So that was a very, very quick overview of AI and machine learning there. And this is where explainability comes in. So you might have heard about machine learning algorithms being black boxes, or machine learning algorithms being transparent. And what this means is what approach do these algorithms use to make their predictions. So a decision tree is an example of a transparent machine learning approach. And that's why, and this is a case where you can actually see how a decision tree is built, where splits are made in the tree, and this builds up, a transparent set of rules as to why a decision was made. At the other end of the spectrum, you have these opaque boxes. For example, a deep learning neural network, which you can see here. So this is a graphical representation of a deep learning neural network. And you have your inputs on one side and your outputs on the other side. And the role of a deep learning neural network is to approximate the function that maps the input to the output. And you can see here that it's very complex. There's a lot of connections here between the different nodes. And essentially, it's a black box in terms of the network structure from these different connections. Doesn't necessarily map back to the structure of the function that's approximated. So we're not really too sure of what goes on at these different hidden layers. Then to follow on from Roger in terms of machine learning and fraud and anti-money laundering detection, it's a really, really tricky, challenging problem. Firstly, because the fraudulent activities themselves are quite a rare phenomenon compared to all activities as a whole. And also your criminal behaviours continually adapt. So as Roger was saying about the constant cat and mouse game. So once you identify one sort of signal or pattern of fraudulent activity, this can be adapted or changed, and then your models, it's out of date. But where machine learning can be applied is that it can uncover these patterns across large volumes of streaming transactions. So you can have many different data real-time data, and so on. And you can use ML approaches to try to extract or identify patterns across these large volumes of data, which just wouldn't be possible for a human to do. And there are a number of different approaches for this, using both our supervised and unsupervised approaches. So you can use like behavioral profiles, so interpreting the different behaviors of accounts and devices and individuals and tracking them across time. You can use your supervised machine learning approaches. So this is where your models are trained on a rich set of for example, labeled transactions. The issue is that it requires large volumes of labeled data to learn from that best reflect these legitimate behaviors. And what underpins all this as well is that your data is clean and it's representative in order to make accurate predictions. So you don't have those false positives or false negatives that Roger was previously talking about. And then you can also have your unsupervised models, and these are models which are really trying to detect anomalies in the data and the transactions. So you're trying to identify those transactions which are a bit different and not necessarily following the norm or conforming to what the majority are doing. And I suppose embedded with all this as well is that you do need sort of human in the loop expertise to guide all these approaches. And to highlight here, I've got it at the side, that the no free lunch theorem applies here as well. So unfortunately, we don't have one key approach that will detect all fraud, or one key machine learning algorithm which outpaces them all. Really, what you need to do is to use a blend of these approaches, and you need to constantly monitor these and adapt, as Roger was saying, that the criminal behaviour also adapts then as well. And the bedrock of any machine learning project or machine learning application is this need for data quality, which I think rings and speaks to the association here. So you've got complexity in terms of the data volume and velocity and veracity of the data that you're analysing. And the data that is ingested by your models needs to be a quality of data. So it's overused, but this saying it's a garbage in and garbage out. These machine learning models, at the end of the day, they're statistical and mathematical models. They're not magic, and they need good quality data in order to perform well. And it's also then, in terms of an explainability point of view, to have that tracking and understanding of the data lineage. What transformations have been performed on it? Has it been integrated with other data down the line, and so on? And then finally, adhering to regulations in terms of security and privacy, and so on. So I've included this example here this evening, and this is a very recent example of when the data goes wrong and the implications that it has in machine learning projects. So this is on the tiny images data set. So the Tiny Images dataset is an open dataset gathered by MIT. And it has about 80 million images, which are tiny. So they're 32 by 32 pixels. And these images, these 80 million images, have been labeled to describe what is in them. And it's a very famous and widely used data set. And it's been used to teach machine learning systems to identify and list people and objects in pictures. But the labeling of the data set was done in part using some of the data in the WordNet data set. So the WordNet data set was developed by linguists in Princeton back in 1985. And it contains words and its relations. And I don't need to point out that we're currently in 2020. So it's, so firstly, it's using a very, very old data set to label some of the images within this data set. And in fact, it was found that a lot of these images, or some of these images, contained racist and gender slurs, which were then embedded into the labels within the Tiny Images data set. And then you can see then how this is propagated through the system. So these biases then are encoded in training data, which were then used by many different machine learning systems to teach them to, for example, identify people and objects. So the original data in the WordNet data set, the sort of the biased, stereotyped, inaccurate information was propagated through the Tiny Images data set, which is then propagated into many different real-world applications. And MIT has taken down the data set within the last 2 weeks. So I think this example, it really, I suppose, pushes home the importance of being able to track the provenance of your data and to address any problems discovered in an upstream data source. And also then, as machine learning it's a relatively new discipline in terms of being used in production. And as such, we don't have established standards for documenting models and data sets. And these type of examples really emphasize the importance then of documenting models and data sets to identify biases and so on before they take root. Okay, so I'm just going to come back to a real life use case where we have implemented machine learning in the area of entity resolution. So entity resolution is an important part of the Know Your Customer process. For example, you're an institution and you're onboarding a new client, and you need to match the client against internal and external data sources, just to make sure that they are who they say they are, so you're able to verify their identity. And actually, there's a lot of time spent in the manual review stage where some of the data sets which you're comparing the client against are often messy and slightly inaccurate, and they might have misspellings and so on. So a lot of time spent in manual review by people to determine, is this person who they say they are, and is this a match or not, before their information can be persisted to a legal entity master. And it's this manual review stage is where we've looked at using machine learning to address this, this manual repetitive task. And we built a machine learning classifier, which reduced the manual review process of entity resolution by 45%. And this then allowed the review team to focus on more of those edge cases where it wasn't quite clear cut if there was a match or not between entities. And we also seen an improvement in terms of data consistency and using this idea of human in the loop machine learning to improve the classifier and to guide reviewers' decisions. And we used 2 open entity use cases, data sets, the Refinitiv Perm ID. We matched it against the global LEI ID. And it was an augmented approach. So it was augmenting, traditional rules-based approach with machine learning to make predictions on entity matches. And we used human-in-the-loop machine learning to help us train and improve our classification process as well. So I think bringing it back to how this maps to the association in terms of machine learning, explainability and monitoring. For machine learning projects, it's you need good practice in data management. So that's in terms of ensuring that the data that you have is complete and accurate, and being able to monitor the quality of that data, to understand rules that were applied to that data, to understand the lineage of the data, where it came from, how it was maybe pre-processed along the way. Whenever you're constructing your training data set, how did you engineer the features within that data set? How did you label that data set? And were you able to capture maybe some expert reasoning in that labeling process? And then moving on to, I suppose, more of the machine learning side, what is the good practice in models and data sets? So machine learning projects, they differ from traditional software engineering projects, where you not only have to monitor the code, but you also have to monitor the data set as well. And this is really important in terms of explainability, in terms of being able to say, how a model made a prediction, what data set it was trained on, and what features then drove that prediction. And then from a statistical point of view, you can have explainability metrics for those transparent and opaque machine learning approaches, such as Shapley values and line. And these approaches, they help provide a bit of insight into what features drove a prediction, which can aid in explaining how a model has come to an outcome. And just to really highlight that machine learning models are cyclic, and it's really important to monitor these models. And going back to the AML and the fraud detection, to address something that's called concept drift. So the model that you have built for example, fraud detection, to make sure that it stays fresh. Sometimes it can drift in terms of the data that it uses. It might be very different to the data that's being used to predict on, or the problem has drifted. So the criminals have a new pattern now, or they have covered the tracks on the previous pattern that you have been tracking. So this whole monitoring side's really important. And then some closing thoughts on this. We're at a really interesting phase in terms of AI and machine learning. And there's been many initiatives and good initiatives from governments and companies and academics on how we should govern AI and machine learning and the ethics then that surround that. So, for example, in the UK, we have the UK Office for Artificial Intelligence, and in Canada, we have the Pan-Canadian Artificial Intelligence strategy. And I think what's quite interesting coming from all of these different initiatives is that we have the same terms that come up again and again. So how can we make sure that the ML process that we are applying is fair, it's transparent, it ensures privacy, for example, of the data, who's accountable for it, and it's secure from adverse attacks. So these are, very commendable initiatives, but there is this gap between these high-level concepts and really practical advice for those who are designing and developing machine learning. For example, in terms of fairness, within mathematics, there's numerous approaches to measure fairness, and each can give a different outcome. And in terms of fairness, a lawyer interpreting fairness could be a different interpretation from a computer scientist. So these are all interesting issues that we are currently grappling with at the moment. And that current regulation that we have, such as GDPR over here in the UK and in Europe, it does go some way to address issues such as data privacy, but it doesn't go the whole way in covering the complexity and the cyclic nature of machine learning algorithms. So that was some closing thoughts there for us.
Well, thank you very much, Fiona, Roger. This has been a fascinating session. I'd like to point people to links we'll be putting in the YouTube session right now for both NEOS and Detactics. So you can go to their websites and see what's up. And learn more about money laundering. I'd just like to sign off by saying thanks everyone for attending, and please look out for our next meeting, August 19th, where we have the prior CTO of World Bank talking to us about data literacy today. Thanks so much, everyone, and have a lovely evening.
Oh, one other thing, just as a heads up, we're currently looking for volunteers for board members. So if you are interested in helping us make EARMAC keep chugging along, shoot us an email at onlinecontent@earmac.ca, or look forward to our blast to our members and to our posts on LinkedIn for more information about what we're looking for.
Okay.
Thank you.
Thanks so much, everybody, for your time.
Thank you,
Good night.
Fiona.